Today I am going to discuss how to calculate the quantities of RCC beam. So this is the sectional view of RCC beam, and we will calculate the quantities of this RCC beam. Before calculation, we have to know about those different bars that are used in this RCC beam. Also, we have to understand how to calculate the length of these bars. After that only, you will have no confusion at the time of estimation. So first, let's start with the length of straight bar. Okay, so this is the straight bar. The total length of this bar will be the length of the bar plus hook length. So this portion is known as straight portion, and these are those hook portion. So hook length is 9 into d. Here d is the diameter of the bar. If you have provided two hooks, then it will be 2 into 9 into d. So total length of the straight bar will be straight length plus 2 into 9 into d. And the next is bent up bar or crank bar. So don't confuse at the time of RCC design, because the bent up bar and crank bar is the same. For calculating the length of this bar, first you have to determine the straight length, then you have to add the bent up length. The bent up length is 0.45 into x. 0.45 into x. If bent up is provided in single side, then it is 0.45 into x. If bent up is provided in the both side, then you have to consider 2 into 0.45 into x. So the length of the bent up bar or crank bar will be straight length plus hook length plus 2 into 0.45x. So here x is the vertical center to center distance between the upper and the lower portion of the bent up bar. So from this center to center distance to this distance is the x distance. So our next bar is stirrup bar or lateral ties. By using one simple formula, we can determine the length of stirrup bars. So that is 2 into a plus b plus 24d or 0.15 meter. 24d or 0.415 meter. Here a is the vertical distance, in vertical distance between these stirrup bars, and b is the in horizontal distance between the bar. So this portion is known as a and this portion is known as b. So there are two bars for horizontal and vertical each. So if this is known as a, here this is 1a and this is second a. So here this is the first b, so this is the second b. So that is why we have to use 2 into a plus b. So next portion is 24d or 0.15 meter is for hook length. Okay, so this is the hook length for single hook, that is 12d, and this double hook, that is 24d. These are also known as leg length of stirrups. So these are the legs, and here we have provided two legs. Okay, so 12d for single leg. Sometime we may take 10d for one leg. Okay, so don't confuse. So 24d for two legs. Here d is the diameter of the bars. After calculation of 24d, if it is less than 0.15 meter, then we have to consider 0.15 meter. It means 24d and within between 24d and 0.15 meter, which one is bigger, we have to consider that only. So this was the length calculation procedure of different bars that we have to use in RCC beams or columns. Now this is the problem. And you have to calculate the quantities of the following items for a beam shown in the figure. So item number 1 is reinforced concrete. That ratio is 1:2:4. Second item is formwork for beam, and third item is weight of the steel in kg. You have to determine from this particular plan that is given, and these are the sections. And the fourth item is preparing bar bending schedule, that is known as BBS. Okay, bar bending schedule. So these are the four items we have to determine the quantities from this plan and section. That is the problem. So for item number 1, only you have to calculate the volume. Okay, item number 1 is we have to determine the quantities of reinforced concrete. The ratio is 1:2:4. That is item number 1. So for this item number 1, we have to only calculate the volume of the beam. That is very easy. We will do it briefly after some time. So in the item number 2 is the formwork. So formwork is the temporary wooden box that we have to prepare before casting for providing proper shape of a beam, and the concrete is poured into that box, or you may say different materials are poured into that box. So that box is known as formwork. The quantity of formwork you have to determine under this item number 2. And the third item is weight of steel. We have to determine, that is in kg. It means weight of reinforcement we have to determine in kg. The last item you have to prepare is bar bending schedule. So we have to determine these 4 items. For that, first we have to analyze this beam. We have to understand the different sections, different lengths provided in the beam. Also we have to understand the position of different bars provided in the beam with the diameter, spacing and weight. To determine the quantity of different items, at first you have to take a measurement sheet. So the format of the measurement sheet is like this. In the first column we have to enter item number, second column we have to enter description of items, third number of items, and fourth length in meter, fifth width or breadth in meters. In sixth column we have to provide height in meter, and in the final column, after multiplying these 4, we will get the quantity in meter cube, or sometime in meter square, or in kgs also. So here our first item is reinforced concrete. The ratio for this concrete is 1:2:4. Calculation of reinforced concrete quantity is very easy. From the plan you will get the length, width, height, and then multiply then for volume. For the length of this beam, the in-to-in length is given, and that is 7 meter. Let me show you. So from the plan you can determine the in-to-in length that is given, that is from here to here, that is 7 meter. Okay, so in-to-in length is 7 meter, and we have to include that also beam is supported on the wall of 0.3 meter thickness of this particular wall. So we have to include that 0.3 meter plus 0.3 meter for these two walls with the in-to-in length, because the beam is extended up to the outer side. Okay, so this is the position of the beam. In-to-in diameter is 7 meter, and that is supported on the wall both side, and the wall thickness is 0.3 meter. So we have to consider this 0.3 plus 7 plus this 0.3. So the length of our beam is 7.6 meter, and height of the beam is given in the plan, and that is here the height of the beam is given, so that is 0.5 meter. Okay, so from section A dash, okay, so from section A dash we will get the width of the beam also. So the width of the beam is, this is the width of the beam, and that is given 30 centimeter, that means 0.30 meter. Okay, so this section, इसमें जितना भी है ये सब डायमेंशन सेंटीमीटर में गिवन है, और ये प्लान में जो भी दिया हुआ है ये सब मीटर में है. So for this particular 30 centimeter, that is our width, that is our height, width. So this is our width, and that is, if we convert it in meter, that will be 0.30 meter. So now we know the length, breadth and height of the beam. So length, breadth and height of the beam, so we have to multiply them. So now we can find quantity of the reinforced concrete easily by multiplying that length, breadth and height. Okay, so and the quantities after multiplication we get 1.14 meter cube. So this is the quantity of reinforced concrete. The ratio is 1:2:4. The next item that we have to determine the quantity of formwork for the beam. Already I have told you what is formwork. Now I am going to show you how to calculate the quantity of formwork. For calculation the quantity of formwork, first you have to understand where and in which portion, in which side the formwork is required. Okay, let me show you. So first we have to provide formwork in the bottom side, ताकि जब हम सीमेंट कंक्रीट इसमें डालें वो नीचे ना गिरे, and that number will be 1. So this is the bottom formwork from here to here. So these are the walls given in the plan. The thickness of this wall is 0.3 meter and this side is also 0.3 meter. So the number will be 1 for any individual beam, and also the dimension of the bottom formwork will be length into width of the beam. For bottom length we don't have to consider the wall thickness. Also we don't have to consider the height of the bottom also. Height of the formwork we don't have to consider. So length of the bottom formwork is 7 meter and the width of the width or breadth is 0.3 meter. So the area will be length into breadth or width. So it will be 7 into 0.3, that is coming 2.10 meter square. So next we have to consider next we have to provide two formwork for both sides. Okay, so here we have to consider length and height of the beam for area calculation. Here for length we have to consider 7.6 meter including this both wall thickness. For height we have to consider 0.5 meter because that is given in our plan, that is the height of our beam. So also we have to provide side formwork in the both side, so the number will be 2 here. So after multiplication of length into height into number we get 6.7 into 0.5 into 2, so that is coming 7.60 meter square. After that also we have to provide formwork for two ends. So here we have to consider height and width of the beam for our area calculation. Here height is this is the height dimension of height. So height is 0.50 meter, that is provided in our section in our plan, and the width is, that is the width, and the width is 0.3 meter. For two ends we need two formworks. So after multiplication of height into width into number we will get 0.5 into 0.3 into 2, that is coming 0.30 meter square. So total formwork, so here for bottom area of formwork is coming 2.10. For sides, two sides are there, the area is coming 7.60 meter square, and for the ends formwork, the two ends we are required to put, so there the area is coming 0.30 meter square. So the total area is 10 meter square. So that is the total area of our formwork. So our next item is steel. For number of bars, diameter and spacing, everything you have to follow reference that is given in our problem. So here this is the reference. So in reference per meter weight is also given. If the per meter weight is not given, then it means if unit weight is not given, then you have to use one simple formula, that is d square by 162. Here d is the diameter of the bar. By doing this you will get the unit weight. So you can easily determine the weight of bar per meter, it means the unit weight. So let's start with the type A bar. So here type A bar is 20 millimeter and diameter of this type A bar is 20 millimeter, and that is straight bar. From reference we got three number of 20 millimeter diameter straight bars, and unit weight is 2.5 kg per meter. Already I have told you how to calculate the length of the straight bar. Here for this bar the straight length is 7 meter plus 0.3 for both side walls. Next, for hook length, we have to add 2 into 9d. So here the diameter is 20 millimeter or 0.02 meter. So hooked length will be 2 into 9 into 0.2. So that you have to add with straight length. So here we have taken the length of the straight bar out to out, but our bar is not provided along out to out. There are some portion for cover. Okay, so there are some portion for cover. So this is the cover portion that you can check from our plan. So this is the cover distance, and the given distance is cover distance is 5 centimeter or 0.05 meter on both side. Okay, so that is given on both side, here and here also. So we have to deduct that portion from the length of our that we have considered out to out. So total length will be 7 plus 0.3 plus 0.3. 7 for into in dimension, 0.3 for single wall thickness, and again 0.3 for another wall thickness, 2 into 9 into 0.02 for hook length, and minus 2 into 0.05 for the cover portion, that is free portion. So the length is coming 7.86 meter, and the number of bars that is given in our reference are 3. Okay, so here from here you can check the number of type A bar 20 mm diameter straight bars are 3. So we need to so we have to take 3 as the number. Okay, also per meter weight is given, and that is unit weight. So that is 2.5 kg per meter. So we can determine the total quantity or weight of straight bars easily by multiplication, and the weight is 7.86, that is length, into 2.5, that is kg per meter unit weight, into 3, that is the number. So that is coming 58.95 kg. So this is the total weight of our straight bar, that is 20 millimeter diameter straight bar. So next is B type bar. B type bar is bent up bar or crank bar. From reference we get there are 2 bent up bars of 16 millimeter diameter, and the unit weight of this bent up bar or crank bar is 1.5 kg per meter. Now first we have to determine the length of 16 millimeter bent up bars. The formula that I have already told you, that is straight length plus 2 into 0.45x. For straight length we have to follow the previous method, but the diameter of the bar has changed. So here straight length of the bent up bar will be L equal to 7.6. It means 7 plus 0.3 plus 0.3 equal to 7.6 plus 2 into 9 into D. So here D is the 16 millimeter, so 0.0616 meter. So plus 2 into 9 into 0.016 minus 2 into 0.05. So that is the cover area that we have to deduct from the length, because we are taking here 7.6 means out to out dimension, but there are some cover area in each section that we have to deduct. So that is why we have to deduct this only. So the length is coming 7.79 meter. Now you have to determine the length of x. X is the center to center vertical distance between top and bottom portion of the bent up bar. Okay, let me show you. So again I am showing you. So this portion is the x portion. So now you have to determine the length of the x. So again I am telling you what is x. X is the center to center vertical distance between top and bottom portion of the bent up bars. So for x, first we have to take the total height of the beam, and that is 0.5 meter, 0.50 meter. Then we have to deduct the cover from both sides, 0.025 meter. So we have to deduct from both sides. So we have to deduct 2 into 0.025 from the total height. Next you have to deduct the stirrup diameter from both sides. from the reference you will get that 10 mm stirrups are there. 10 mm stirrups are provided at the both side. So we have to deduct 2 into 0.010 meter from the total height. So here for x we have to find out the center to center distance of our bent up bar, and the diameter of this bent up bar is 16 millimeter. So we have to deduct 8 millimeter from the top and 8 millimeter from the bottom. You can here check, जो हम बोल रहे हैं वो कैलकुलेशन इधर हो रहा है. You can check here. This is the deduction for cover, this is the deduction for stirrup, and this is the deduction for the center to center distance. So we have to deduct 8 millimeter from top and 8 millimeter from bottom. So total 2 into 0.008 millimeter we have to deduct from the height. So the length of the x will be 0.50 minus 2 into 0.052025 minus 2 into 0.010 minus 2 into 0.008. So that is coming 0.41 meter. Now we have our straight length and we have also the length of x. So from the formula we can easily find out the length of the bent up bars. So the total length of the bent up bar will be 7.L plus 2 into 0.45x. So L is 7.79 plus 2 into 0.45 into x, that is coming 0.41. So the length will be 8 point, after multiplication the length will be 8.16 meter. Now we have total length of bent up bars and the number of bars are 2. We know the unit weight that is given in our reference, that is 1.16 kg per meter. By this we can easily determine the total weight of the bent up bar or crank bars. After multiplication we got that is 26.11 kg. So this is the total weight of our type B bent up bars. So next is type C bar, but according to the reference it is also 16 millimeter bent up bars. So the straight length calculation will be same and the length will be similar, like 7.79 meter. That is similar to the previous bent up bars. Okay. So now for calculation x, from the height, first we have to deduct the cover. So the height is same, the beam height, that is 0.50 meter, and the cover distance is same, that is 0.025 meter at the single side. So we have to deduct the cover distance for both sides. So it will be 2 into 0.025. Next we have to deduct the dimension of diameter of stirrup bar from both sides. So it will be the deduction will be 2 into 0.010. Next, for center to center distance we have to deduct 8 millimeter from the top and 8 millimeter from the bottom. So the reduction will be 2 into 0.008 meter. But from the section you can find that between two bent up bars in the bottom there is a straight bar of 20 millimeter, and also there is a spacer bar of 20 millimeter. So those also we have to deduct from the height. So for that particular straight bar 20 millimeter diameter and spacer bar 20 millimeter diameter, those we have to deduct from the bar. So the length of x will be 0.50 minus for cover area 2 into 0.025 minus for the dimension of the diameter of the stirrup bars 2 into 0.010 minus, that is the straight bar provided in the single end, and that is the spacer bar provided between two bent up bars. Okay, so last, that is the 8 millimeter from top and 8 millimeter from down, that is for center to center distance. So our x is coming 0.378 meter. Now the length of the type C bent up bars will be L equal to 7.79, that is the straight length, plus 2 into 0.45 x. So x is here 0.378. So the equation will be 7.79 plus 2 into 0.45 into 0.378. So that is 8.13 meter. Now we have total length. Now we have total length of type C bent up bars, and number of bent up bars are 2. That is given in our reference. You can check from here. Also we know the unit weight of that particular bent up bar, type C bent up bars, that is also given in our reference, and the unit weight is 1.6 kg per meter. So the total weight of type C bent up bars will be 26 kg. After multiplication we are getting 26 kg as the total weight of type C bent up bars. Next we are going to consider, that is type D bar. From reference you will get that type D bar is 20 millimeter diameter anchor bars. So anchor bars are similar to the straight bars. Length of the anchor bars calculation will be same as the straight bars. Okay, first we have to calculate the straight length, then we have to add the hook length. Next we have to deduct the cover distance from the total length. So straight length is 7 plus 0.3 plus 0.3, that 0.3 is for wall thickness. So the total length is 7.6 meter. Now addition of hook length is there. So 2 into 9 into D, we have to add this portion with the straight length. So the diameter is 12 millimeter. So we have to add for hook length is 2 into 9 into 0.012. So here cover distance is also same, that is 0.05 meter. From both sides we have to deduct the cover distance. So deduction will be 2 into 0.05 meter. So the length will be L equal to 7.6 plus 2 into 9 into 0.012 minus 2 into 0.05. So that is coming 7.72 meter. From reference we are getting that the two numbers of anchor bars is there, and the unit weight of that particular anchor bar is 0.89 kg per meter. So the total weight of type D anchor bars will be, after multiplication of length into unit weight into number, that is 7.72 into 0.89 into 2, that is coming 13.74 kg. So this is the weight of 12 millimeter dia anchor bars. So next we have to consider, that is E-type stirrup bar. From reference we are getting the diameter of the bar, that is 10 millimeter, and the number of this stirrup bar is 38, and the unit weight is 0.62 kg per meter. Already at the starting I have told you that the formula used to determine the length of the stirrup bar is 2 into A plus B plus 2 into 12D. So first we have to determine the length of A. For that we have to check proper section. From the plan we can find E-type stirrup bars, and for that we have to select section BB dash. Okay, so this is the section BB dash, and so from that section A length is this length, that is A. Okay, that into in vertical distance length, that is A, and total height is here. Our total vertical height of this beam is 0.5, that is 50 centimeter, that means 0.50 meter. Now we have to deduct cover area from both sides. So our cover area is same, always same, that is 0.025 meter. So deduction for both sides is 2 into 0.025 meter. Because the length A is into in dimension, so we have to deduct the diameter of stirrup also from the both sides. So that is 2 into diameter of stirrup is 10 millimeter. So we have to deduct 2 into 0.010. So length of A will be 0.50 minus 2 into 0.025, that is for cover area, and that we have to deduct. And the next deduction is 2 into 0.010, that is for diameter of stirrup bar. Okay, so the length of A is coming 0.43 meter. Now for horizontal B length, so that length into in dimension is B. Okay, that into in dimension for this section, that is B. So for horizontal here for horizontal B length, we have to deduct the same cover area and same stirrup diameter from the width of the beam. So here width of the beam is, that is given here, 30 centimeter, that means 0.30 meter. So the length of the B will be 0.30 minus 2 into 0.025, that is for cover area, minus 2 into 0.10, that is for the diameter of stirrup. So the length of the E-type, so length of the B is, that is coming after calculation, that is 0.23 meter. So the length of the E-type stirrup will be L equal to, we know the formula, L equal to 2 into A plus B plus 2 into 12D. So here A is the 0.43, B is 0.23, and diameter is 0.010. So length is coming L equal to 2 into 0.43 plus 0.23 plus 24 into 0.010. So that is coming 1.56 meter. Now we got the length, and unit weight is given, that is 0.62 kg per meter. So in this reference number, the number of stirrups are also given, that is 38. Okay, so total weight of type E stirrups will be 38 into 1.56 into 0.62. So that is coming 36.75 kg. That this is the total weight of type E stirrup. Now you can check from this reference, type F and type G is also stirrups, but the dimension is different. So for similar calculation we have to do type E stirrup. After that I am not doing again this calculation, that is similar, but the dimension is changed, so little bit change is here. So after total calculation we got the type F, total quantity of type F is 7.34 kg. Same calculation similar to the type E stirrup, we got 7.34 kg as the total weight of type F stirrup, that is of 8 millimeter diameter. And the next type is G, that is also similar calculation we have to do like type E stirrup. After that we will get the quantity in kg. Here we get 3.63 kg for type G stirrup. So type E, type F and type G is similar, so the calculation is also similar. The dimension is different, so there is little bit difference is there, so for that particular dimension also. Next the last type of bar is type H bar, that is spacer bar, or that is known as pins bar also. In the reference, the diameter of type H spacer bar are given, and it is 20 millimeter. The number of pin bars here the dimension is 20 millimeter and the number is 11, and the number of pin bar and or spacer bar are also given, that is 11. The length calculation of spacer bar is very easy, because this is pure straight bar. We don't have to provide any hook in this spacer bar, because it is used only to maintain the distance between two bars. Okay, so it is used only to maintain the distance between two bars. So this bars is provided laterally, not longitudinally. So we have to consider thickness for the length calculation of spacer bar. The width of our beam is 0.30 meter and the cover is 0.025 meter in single side. Here also we have to deduct the cover from both sides. So length become 0.3 minus 2 into 0.025. So that is coming 0.25 meter. So the length of our spacer bar is 0.25 meter. In the reference number, number of spacer bar is given also, and that is you can check from here reference. The number is 11. Now we have length of the spacer bar, we have our number, we have our unit weight also, and that unit weight is 2.5 kg per meter. So that is given also in our reference. So the total weight of type H spacer bar will be, after multiplication of length into unit weight into length into unit weight into number, we are getting the total weight of our type H spacer bar, and that is 6.88 kg. So these are the total calculation of item number 3 up to item number 3. So the now for this beam, total quantity of steel required, that is coming after addition of total A, B, C, D and H type bars, that is coming 179.40 kg.